This is Orekoya Olusegun Mathematics Fundamentals on YouTube. Physics Mathematics Fundamental on YouTube. Please, before we go into today's topic, do not forget to share, like, subscribe, and click on the notification button to be able to have more of my video. Today, we are taking a course under mathematics, and this particular topic we are going to take is under analytical geometry. And under analytical geometry, we are going to deal with exercise on hyperbola. And I will rather suggest that you check on my previous videos on the introduction to conic sessions. There, you will also learn about the general equation of the conic section and how to identify a given equation to be able to know whether it represents a particular conic section. Now, today we are going to discuss on how to find the vertices, the foci, the equation of directrix, the eccentricity of a conic section. That is a hyperbola. Now, hyperbola has this curve, this particular curve here, and we have a foci f1 and foci f2 there. The distance from this vertical axis to this place is a, and this vertical axis to this foci is c. And you know, this particular conics has other parameters. Relationship between those parameters that I have, c squared is equal to a squared plus b squared, which means c is equal to square root of a squared plus b squared. So we are talking about the major axis and the minor axis of the parabola. If the a, which is greater than, this one represents where the a is. If it's greater than where the b is, then that particular hyperbola is along the x-axis. Now, the general equation of an hyperbola is given as x squared all over a squared minus y squared all over b squared is equal to 1. Now, if you compare this equation to this question that I have here, I can think about a number that I'm going to square to give me 16 and think of a number I'm going to square to give me 9. Those numbers will be 4 squared minus y squared all over 3 squared is equal to 1. So what I have here is exactly the same thing as this equation that I have here. And if you compare this equation I have here with this equation, we can really see that our a is 4 and the b is 3. Now, other thing that we need to find is the vertice, then the foci. The foci is plus or minus a, 0, and the vertice is plus or minus c, 0. Then we talk about directrix. Directrix. So in this particular directrix, we are going to use certain equation to be able to find an expression for the directrix. So here, the d that I have here stands for the directrix, and the e that I have here stands for the eccentricity that we are going to look for. Now, coming to these particular parameters I have here, we know that we can easily get the coordinates of the foci. Since a is 4, so my foci f that I have here cannot be plus or minus 4, 0. Now, to be able to find the coordinates of the vertices, which is plus or minus c, 0, we know that the relationship between c, a, and b is given by this expression. So the c now, the c that I have here is actually square root of a squared plus b squared. Since the a is 4 and b is 3, so I'm going to have 4 squared plus 3 squared, which is 16 plus 9, which is square root of 25, which is 5. So the value of C is 5. So in a nutshell, the vertex that I have here now, the vertex now will now be plus or minus 5, 0. So we have been able to solve the question I and II. So the question I now is what I have here, and the question II is what I have here. Now, to be able to find the equation of the directrix, let's go to these particular parameters I have here. We have relationship between the major axis A. When we square it, is directrix times this C. And this C, in this diagram, is the distance or the foci from this vertical axis here. So I have this C. And the C that I got the other time is 5. And the A that I have is 4. So I have 5 squared is equal to D times C times 5. So no, A is 4. So 4 squared is equal to D times 5. So 4 squared is 16. 16 over 5 is equal to D, which is the equation of the directrix of the ellipse. So the directrix is III. So we have solved the problem for III. Now, the eccentricity E, we can use this equation. Like myself, if I want to remember this equation, I will use the word, the name of Ade. So if you are a Yoruba person and you know somebody is bearing Ade, you can use it to remember that. Then from this Ade, I can also remember this. I will just square this A here, and this E, I will just clean up this part of the E, become C. So that's how you can get this second one from this first one here. So now to get the eccentricity E, I'm going to use this equation. A is equal to DE. Since my A that I have is 4, then the D that I just got there is 16 over 5. 16 divided by 5 is times E. So we make E solve the formula. So in a nutshell, the E now will now be, you cross multiply, or 5 in 15. Before I cross multiply, I can have this. So the D that I have here is 16 over 5. 16 over 5. 16 over 5. So now I can cross multiply. So I have 5 times 4 divided by 16 will give me my E. And 4 can go in 16. 4 here 1, 4 in 16, 4. So 5 divided by 4 is the eccentricity E. And 4 in 5 is 1 point. In 10 is 2. Then in 20 is 5. So the eccentricity of this particular hyperbola given here is E is equal to 1.25. That is the solution to the question over IV. Eccentricity is 1.25. So you can see that this eccentricity is greater than 1 based on the relationship of eccentricity. We know that for eccentricity of eccentricity fall between 0 and greater than 1. Eccentricity that's greater than 1 here is for the hyperbola. The eccentricity that is 1 here is for the parabola. Then the eccentricity between 0 and 1 is for the ellipse. Then the eccentricity that is 0 is for the circle. I did this particular one in my last video. I believe that we've learned 1 or 2 things concerning my presentation on solving a problem involving determining the relevant parameter that describe a given hyperbola. Thank you for watching, and I believe that you'll be looking forward to more of my video. Have a nice day. Bye bye.